Now, let's have a practice to calculate the oxidation number of the following. Look, number 1A, for chlorine, we said that the oxidation number of any element equals 0. Now, what about the chlorine inside this compound in P? Here, we're gonna write a mathematical equation that equals 0 and calculate here the oxidation number of chlorine as AX. Okay, and here oxygen you will put it, not calculate it. So when you put it with the common oxidation number -2. So here chlorine equals, oxidation number of chlorine equals positive 7. Why? Number 2, we need here sulfur in sulfate atomic group. If we have atomic group, we also write a mathematical equation, but this time it will be equal to the charge of the atomic group, like in number 2A. So here, this equation will be equal -2. And at the end, sulfur equals, its oxidation number equals positive 6, and so on. But what about the importance of oxidation numbers? We can use it to know the change that occur for some chemical reactions, for redox reactions. I mean oxidation and reduction reactions. You studied them before in Model 3. Oxidation is the process of losing electrons resulting in an increasing of the positive charge, while reduction is the opposite. Now, if we have an equation like this, and we wanted to explain the type of a change, which means oxidation or reduction that occurred to iron and carbon in the following reaction by using oxidation number. Here, we're gonna calculate the oxidation number for iron before and after the reaction, and the same with carbon. And if the oxidation number increases, so it's an oxidation process, and this element is what a reducing agent, and vice versa. So in this example, here the oxidation number of iron decreases from positive 3 to 0. So it's a reduction process and it's a reducing agent. But here, in case of carbon, it's an oxidation process because the oxidation number increases and it's what? A reducing agent. But pay attention. If a part of the equation is reduction, the second part must be a oxidation, or neither nor. But if you have just a part of the equation, just oxidation or reduction, while the other is none, so there's something wrong, and you have to resolve it again. Thank you, Senior 2. That was the last part in our semester this term.